So in this section, we will be learning about mathematical library functions, which can be found in page 23 of your manual. To start off, we know that C++ can handle arithmetic operations, which includes multiplications, divisions, addition, and subtraction, and even modulus, and we learned this one in the previous section. However, if you are going to apply it to engineering problems or even applied mathematics, then those arithmetic operations are not enough. So we need other mathematical equations or operations so that we will be able to handle complex equations and even complex problems. So to start off, the mathematical library functions, if you can view your manual, you can see there some examples, including absolute value, power, square roots, sine, tan, and so on. We will try to explore all of those commands and all of those, and we will try to have an example here in this section. So to start off, when you are going to make use of all the listed mathematical functions, we need to first include the library. As I mentioned last time, in order for you to include specific functions, in this case, we already include the IO stream, which entails or which includes the cout function. So if you are going to use the mathematical functions that is complicated, let's say, for example, absolute, square root, and so on, then therefore you need to include it also at the very beginning of your program. So to do this, we just write there include, and the library that you are going to use is CMath. Okay? So again, when you write this code, you will be able to make use of every functions found in the CMath library. So to start off, let's try one function, which is, or one operation, which is absolute. And we know what is absolute. No? So absolute takes in the positive value of any number. So to do that, let's say, for example, we first create a variable called, or write it as a float. We can say answer. And we will assign this answer to the value, let's say, is equals to 4. And we will try to display this one. So to display, we use cout. And this number is blank. Then we will try to display the value, which is answer. Then, of course, I want a inline so that we can see it properly. So if we run this one, so this is just basic. Now we learned this one in the previous section. If we run this one, we know that the display will be this number is 4. Okay. Now, if you are going to use the different functions in CMath, let's say, for example, absolute. So we can write it like this, absolute value. So if we place that one, you know that this is what's inside now is what we call the arguments. So the argument there will be the same data values. The result of this will be the same data value what's inside or what you write inside the argument. So in this case, since this is 4, then we can say that this result will be an integer, and it will be placed in a floating variable. So it is fine, but once you write there 4.0, it means that the argument, which is a float value, is now stored in a float variable. So if we run this one, and take note that absolute value will take in whether it's negative or positive. So if you place there negative, the result should also be equals to 4. So if you run that one, the value is 4. Okay. So even if we change this one, let's say, for example, 12, again, since we have this function, so everything inside the argument will be we get the absolute value what's inside the argument. So if you run that one, again, the answer is 12. Even it's positive or negative, it will take in the absolute value. Okay, so next one, let's have another example. So a good example there is making use of power. So to use the power command, we use pow. No? So in pow, there are two types of argument. And the two types is the first argument would be your base, and the second argument will be raised to the power. So in case what you're going to write there is 2, meaning 2 raised to the power of, let's say, 4. It means that the value should display is 2 times 2 times 2 times 2 4 times. And the data value of the argument or the result of this will be based on the data value of this one, which is, in this case, since this is 2, which is an integer, therefore the result should also be an integer. But if we say that's 2.0, that it means that the result of this one will be a float, because the argument there, or the argument inside there, indicates that this is a floating number. So if we run this one, we are going to display is 16. Again, the reason why it's 16 is because it's 2 multiplied by itself 4 times. No? Another example, let's change this one to 5.0, and we raise it to 2. So the answer should be 25. And no matter what's the value in your second, data value in your second, whether it's integer or not, it always depends on the first argument. Okay, so if you run this one, we can see that the number there is 25, which is 5 times 5. So another one, good example there is, let's try to make use of square root. So to write the square root of it is basically SQRT. Then let's say square root of 25. No? So the answer should be what? 5, because we are taking the square root of 25. So if you run that again, we can see there that the answer is 5. Again, if you don't include this one, let's say for example we delete this one, or even if you forgot to write that one, then if we run the code again, we can see at the very bottom of our screen, which is the data logs or the build logs, we can see that there is an error for this one. So it means that it does not recognize this function because we did not include it. We didn't include the library for it. So again, we need to write there CMAT. So another one is making use of tan, inverse tan, and so on. So there is an example there. But let's say, for example, you try to find the angle given the length of the opposite of a right triangle and the adjacent length. So let's say, for example, what is the angle given the opposite of 2 and the adjacent of 2? So to do that, basically you want to take in the inverse of tan, no? So that you can get the angle. Now in the example there in your manual, it does not see there the inverse, it's just tan. But to do the inverse, therefore you're going to use a tan. No? So anything that is inverse, you can have there a tan. Or you can invert it by yourself by just saying 1 over tan. Okay, but in this case we will be using the a tan command. So as I mentioned, what is the adjacent? What is the opposite? That's 2 divided by adjacent length, which is 2. So it means that supposedly you have an angle of 45 degrees. Now, if you run this one, you might discover that the value is not 45 degrees. Why is that so? The reason why it's not 45 degrees, because the result is in radians form. So therefore, we need to convert this one, the unitless radians form, into a angle. Okay, so again, if you are going to use tan, tan, sine, and all of those commands in finding the angle, usually they will give you, the computer will give you in radians form. So therefore, we need to convert that one. Now, if my mathematical equation is correct, first let me write there a variable named degree, then degree. So if I am going to find the angle, I need to convert the result answer, which is in radians, into degree. So I need my answer to be multiplied with 180 degrees. And of course, I want it to be divided by pi. Now, pi, I also need to declare pi. So what is pi? I will declare the value of pi. So it is 3.1415. So I just rounded it off. So if I'm going to run this one, I should be able to get the degree form. So instead of answer, so I can say degree. Or even I will try to display it like this. No? This is the answer in degree. I need to copy this. This is the answer in radians. So we have their answer. So if you run this one, so expect that the answer is, this is the answer in radians, okay? And this is the answer in degrees, which is close to 45 degrees. The reason why there are decimal points is because of the value of pi, which I wrote there. Okay, so in your manual, there are lots of examples there. There is log of 10. We can have their exponents and so on. And there are other examples in your manual that you can try to experiment and try to discover on yourself. Okay.